Alright, today we're going to be talking about Chapter 3, Topic 4, which is solving systems of equations using substitution method. Substitution method is just it's a little bit different method of solving systems. It has its own uses. Typically, certain circumstances you would want to use substitution. Most systems of linear equations can be solved, all of them can be solved using elimination method. Substitution method is actually more useful for other types of equations besides linear, and for other, you know, applications. So we are going to talk about it. Here are the instructions. The main idea is that one of your equations will be solved for one of the variables, either x or y, and then you will use the expression that represents that variable as that expression will be substituted into the other equation for that variable. The idea is to, when you do the substitution, one of the equation ends up having only one of the variables in it. I see what we're talking about in this problem, and you can see one of the equations is already solved for x. And we have our system here, 2x plus 5y equals negative 5, x is equal to negative 3y plus 3, and we can see that the second equation is already solved for x. X is equivalent to the expression negative 3y plus 3. So what that means is that x in the first equation can be replaced by the expression that it's equivalent to. It's equivalent to this expression. So what we can do is we can take the first equation, 2x plus 5y equals negative 5, and we can replace this x, instead of being 2 times x, it would be 2 times the expression that it's equivalent to, which is negative 3y plus 3. Okay, so we end up with something that looks like this. The x has been replaced by the expression negative 3y plus 3. This is called substitution because I have substituted an equivalent expression into the place of the variable. And at this point, we can simplify this equation by distributing and combining like terms. So 2 times negative 3y is negative 6y, 2 times 3 is 6, and then plus 5y, and then equals negative 5. And then we can combine our like terms, negative 6y, positive 5y. So we end up with negative y plus 6 is equal to negative 5. We can now solve this for y by subtracting 6, negative y equals negative 11, and then dividing by negative 1 or multiplying by negative 1 to give us y equals 11. Okay, so now that we have what y is equal to, we can go back to the expression that tells us what x is equal to. X is equal to negative 3y plus 3. Okay, so I just need to substitute the 11 into that, so negative 3 times 11 plus 3. Let me put it over here because I'm running out of room. So I got x is equal to negative 33 plus 3. Okay, so x is equal to negative 30. So I have 11 and negative 30. And this would be my solution, the ordered pair negative 30 comma 11. And I did this without having to use elimination, even though I could have technically used elimination. I could have added 3y over and lined it up and used elimination. This is just a different method, and it's called substitution. So I have my solution, and of course I could check my solution, do that another time. So let's take a look at another one. This one is, of course, a system. The second system is solved for y already. We say y is equal to the expression negative x minus 5. So I can replace y in the first expression with what it's equivalent to, negative x minus 5. So the first equation can be rewritten as 5x minus 9 times y, except y can be replaced or substituted with negative x minus 5. Okay, and then 5x minus 9y equals 3. And then once again, same process, I can solve this. First I will distribute, and then I will combine like terms. So I got 5x, negative 9 times negative x is positive 9x. Negative 9 times negative 5, positive 45, equals 3. Combine like terms, 9x and 5x is 14x. And then solve this for x, subtract 45. And I get 14x is equal to negative 42. Divide by 14. So negative 42 divided by 14 is negative 3. So the x-coordinate in my solution is negative 3. Now I know exactly what my y-coordinate is because I have a very simple equation telling me what my y-coordinate is equal to. My y-coordinate is equal to negative x minus 5. So negative 3 minus 5, okay, or 3 minus 5, or negative 2. So the solution here, negative 3, negative 2, for my x and my y. Okay, so this can be a little bit faster than elimination. It can require less work. And if you can solve one of the equations for one of the variables, then this is very easy to do. Now you see in the next example that we don't actually have any equation solved for a variable. Okay, we got our first equation, our second equation, but neither one is solved for a variable, but I'm still trying to use substitution here. Well, very easy solution to this problem, okay? I can simply change equation 2. I can change the second equation so that it is solved for a variable. It's very easy to solve the second equation for y. I can just move the 4x to the other side by adding it, and I get y is equal to 4x plus 3. So equation 2 is y equals 4x plus 3. Now I can use substitution, okay? So I can replace the y in the first equation with 4x plus 3. So that becomes 12x minus 3 times y, but y is the expression 4x plus 3, and it's equal to negative 9. Once again, distribute and combine like terms. So 12x, negative 3 times 4x is negative 12x. Negative 3 times 3 is negative 9. And on the other side, I get negative 9. 12x minus 12x is 0x. Okay, those actually cancel. And I'm left with negative 9 equals negative 9. Now, you'll notice here that I don't actually get a solution. Okay, I get something, I don't have any variables left. I have this thing that says negative 9 equals negative 9. This is actually a special case. All right, when you get a fundamentally true statement during the solving process like this, where negative 9 equals negative 9, this means that the lines we started with, the equations we started with, were the same equations. This has infinite solutions because the lines we started with were the exact same lines. Let's take a look. 12x minus 3y equals negative 9. Negative 4x plus y equals 3. These are the same lines, okay? If you multiply the second line by negative 3, you get 12x minus 3y equals negative 9. You get the exact same thing as the first line. So these are the exact same line. So they have infinite solutions. Every ordered pair for the first system is a solution to the second system. They are the same line. So they have infinite solutions. This happens when you get a true statement during the solving process, okay? What this is saying is that the left side, actually, I was going to say something, but let's move on. Let's take a look at number 4. We're solving this using substitution. Once again, neither of these equations is solved for a variable. However, the first equation is very easy to solve for x. We can add 5y to both sides, and that will solve it for x. We get x is equal to 5y plus 3. Now I can use substitution to replace the x in the second equation with 5y plus 3. So I got negative 2 times x, so times 5y plus 3, plus 10y equals 5. Distribute and combine like terms. Negative 10y minus 6 plus 10y equals 5. Now once again, in the solving process, the y's will cancel and we get negative 6 equals 5. This is a fundamentally false statement. This is not true. Negative 6 is not equal to 5. What this means is that these two lines do not cross. There's no solution here, okay, because this is not solvable. It's not even true. There's no solution here. There is not going to be a way for these to have a solution. And we can see that if we get the first equation to match the second equation. Okay, so the first equation is, if we multiply the first equation by negative 2, we would get negative 2x plus 10y equals negative 6. But look at the second equation. Negative 2x plus 10y is equal to 5. Well, negative 2x plus 10y can't be equal to negative 6 and 5. Okay, there's no way that it can be equal to both of these. It's either equal to negative 6 or it's equal to 5. But there's no way you can get them to be equal to negative 6 and 5 because they're the same thing, but they're equal to different things. Okay, so
please report to 14207. Thank you.
So this has no solution. This is false. All right, and that is our substitution method there.